All right, well, in this part of the lecture, I'd like to talk about some data structures that, for beginners, perhaps maybe are not necessarily some of the most common ones that you'll see, but they're really crucial to Python, especially as you get a little bit more advanced, namely tuples and sets. A tuple, and by the way, some people pronounce this tuple, and I'll just say right out of the gate, honestly, I think that sounds dumb. So I say tuple. A tuple is a list. However, it is a list that cannot be changed. We say in Python, and we'll see this again here in a little bit, a tuple is an immutable data structure. And I know already, I've said this before, I know we all took Latin, but in Latin, mutare is the verb that means to change. And so if things mutate, that means they change. Im means not, so anything that is immutable means that it's not changeable. And a tuple is a list that is immutable, not changeable. The question is, well, why would you want one of these? And there are really two answers to that question. Number one is that it provides, as you see here, a certain kind of guarantee or insurance that this data will not change. It's a little bit like that we've established a contract or a promise with Python, and we say, hey, look, here's some data, Python, but let's just make sure, shall we, that this thing can't change. And so Python says, all right, well, let's just make that a tuple, and then I will honor that promise. Tuples get used a lot in Python, and as we go forward, we'll see that we might ask certain kinds of data structures or certain kinds of things for answers, or ask it for data. And it's often the case that that data will be returned to us as a tuple. It behaves exactly like a list, but it's just not changeable. You'll see this especially in maybe a little more sophisticated applications, like, for example, when you pull things out of a database. If you pull things out of a database, you don't want necessarily to accidentally change it before you push it back into the database. And so oftentimes in an application like that, you'll receive data as a tuple. So here, for example, is just a version of what we were playing with in the last slideshow. This is just a list of friends. Again, I just made these names up. I have no idea where they came from. But in this case, notice that it's wrapped in parentheses instead of square brackets. And that's really the clue. When we put this in parentheses, it doesn't form a list, it forms a tuple. And so this tuple is unchangeable. I cannot add anyone to it. I cannot delete anyone from it. I can't even sort it. It's carved in stone. These things just will not change. We'll play with that a little bit in the after at the end of this slideshow, where we do a little terminal work. So again, just to repeat, there are two reasons and maybe why we would use a tuple. One is exactly this idea about being immutable. Anytime we want data to stay consistent, to remain consistent, to not change, to stay the same, a tuple is a really good choice for us because Python will honor that promise that it won't change. The other thing we'll do, I don't know if we'll talk about this, this is maybe a little bit more advanced, is that Python has some sophisticated ways to do multiple assignments at the same time. It's actually quite clever and quite sophisticated. I'm not sure that we're going to see this. Maybe we'll think of one later. But the tuple is one of the reasons, or one of the ways in which Python can actually make that happen. Admittedly, that's probably not something you're going to see, in a first semester Python course. But the tuple, as you go through your Python career, will probably become more and more important as we move along. The other data structure that I'd like to talk about today, and we'll play with this here in just a minute, is a set. If you've played with things like Venn diagrams or sets in math in the past, this is exactly what it is. A set is an unordered collection of unique elements. And it's important to remember that because sets do not have any duplicate items. And in fact, the example that I'm going to show you a little bit when we play in the terminal window is how to remove duplicate items from a list. we can convert a list into a set, and Python will automatically remove for us all of those duplicates. Now, notice the syntax here that a set uses curly brackets. We've seen those before, right, with dictionaries. But here you can see I've created a set of unique letters, and I'm using a curly brace and then just single strings, A, B, and C. There is no key colon value syntax there. And so by using the curly brackets without the key value syntax, that for Python is a set. If I accidentally listed something like A twice, that's okay. Python would take that out because by definition, a set is only unique elements, right? There's a little function too that I can use, set brackets here, set with parentheses. So I can take a string like the word apple, and if I convert it into a set, you'll notice that I just get the individual letters. It's that word is made up of the letters A and E and L and P. So it's removed the duplicate P there. But again, you'll notice that this is kind of treating, in some senses, it's treating a string as if it were a list. This is one of the blurry areas in Python that is greatly to our advantage. It's one of the reasons that Python becomes such a great text processing and text analysis language, because this line between what counts as a list and what counts as a string are pretty fuzzy as we go forward. Before we get to the terminal, I just wanted to review really quickly this in and not in operation stuff. We talked about this a little bit last time, but I want to show you a little bit more in detail about how we can do that, especially when it comes to something like a dictionary. So remember, and Python has these two Boolean operations for in, or if we want to negate that, not in. And what it does is it says, I want to see if the thing on the left-hand side is contained or not contained in the thing on the right-hand side. Now, that thing on the right-hand side might be something like a string or a list or a dictionary or something else about a dictionary that I'm going to show you in just a minute. And again, to repeat, look at the nice blurriness, that's such a thing, nice blurriness, that Python has for us. We can treat a string as if it's a list. So if my city is London, England, I can check to see whether any of these elements are in that string. Is capital L in there? Yes, true. Is G? Yes, true. Is there an R in the string in the bucket called city? No, that's false. Is there a lowercase e? That is false as well. So when we get to play with this a little bit, remember that uppercase letters and lowercase letters, according to the computer, are not the same. They're actually different characters. So one of the things that I'm going to explain, and we can play with this in the terminal window as we get there, is my joke is that there are not, according to Python or other computer languages, there are not 26 letters in the alphabet. There are actually 52 letters in the alphabet, because a capital letter and a lowercase letter, according to Python, are not the same character. All right. So is there a comma in there? Yes. Is there a K not in city? Why, that is true. Is there a period not in there? That is true too. So in and not in work beautifully for strings, and they also work, obviously, for lists. We saw before that if I'm looking for parts of a dictionary, in and not in only look at the keys in a dictionary. So here's a dictionary of a person. We were looking at this a little bit earlier. If I ask if first is in person, that's true because first as a key is the label on a drawer. And so Python looks at the labels on all the drawers and it says, yep, first is one of those labels. True, first is in person. Same for birth. But now you'll notice if I look for the word Shakespeare, this is the value of the key last. So as a value, it is in the dictionary, But when I ask Python if Shakespeare is in person, it tells me that is false. If I look for a number 2, like 1616, this is the value of the key death. But again, Python doesn't look in there. It's not looking in the values. It's looking only in the keys. So Python says that that's false. That is not, in fact, a key in the dictionary called person. Is citizenship there? True. That is one. And now you'll see what I'm looking at here. Is William in the values of that dictionary? That happens to be true. So this is one of the ways we have to sort of modify, or we ask for a part of the dictionary, and we can use the in and not in operators on that part of the dictionary. Let's look at that in a little more detail. So we'll play with this on the command line in just a second. But if I have my dictionary called person, and I want to see what all the values are in that filing cabinet, I can tell person, I say, hey, person, give me your values. And this is the syntax that I use. I write person dot values and then parentheses, empty parentheses. This is called a method, technically, or if it's unattached, it'll be a function. We're going to have whole units on this. We've got a whole slideshow on objects. We've got 3 slideshows on functions. We're going to cover this pretty thoroughly. So what I can do is I can actually ask the dictionary just to give me its keys, or I can ask the dictionary just to give me its values. And here's what I get. I get William and Shakespeare and 64, 68, all of that sort of stuff. Now, this looks a little complicated, and just please don't panic about this. We already know what our brackets are looking like. This is just a list inside kind of a tuple, so don't panic about all of that. What I get, think of it this way, what I get when I ask a dictionary what its values are, what I get is a list of all of those values. Can I use in and not in on a list? Absolutely, yes I can. So this is how I go about figuring out whether some value happens to be inside there or not. So this is what I can ask now, is 1564 in person dot values, and Python will tell me, in fact, yes, the answer to that is true. So remember that if I'm using in and not in with a dictionary, unless I specify otherwise, it's only looking at the keys of that dictionary. I can ask it to look in the values of the dictionary. I just need to do a little bit of an extra step here. That's not very onerous, I think. All right. We have already seen a number of brackets. And so I wanted to review those here because we've seen about as many as we're going to see, at least for a little while. And there's really no other answer here except memorization. You just really, really, really have to memorize them. And so when we get to a new part, if you look ahead a little bit to some of the slideshows, we're going to work on comprehensions. When we get to comprehensions, it's really crucial that you remember these brackets because we're not really going to have any other clues about our data structure except what these brackets are. So we have to memorize these, learn them, again, write them on a Post-it note, put that Post-it note on your head, and then walk around with that for, about a week, and then you'll just remember all of these. So again, lists use square brackets, and anytime you see something that is being created with square brackets, you know automatically that thing is a list. If we see curly brackets, and you see this kind of key colon value pattern inside curly brackets, then you know that what that thing is a dictionary. It's always going to be key colon value because a dictionary by definition is a series of key value pairs. So creating the dictionary, we have to have obviously key value pairs. So if you see key value pairs inside curly brackets, you know that thing is always going to be a dictionary. By contrast, look at the bottom here. If you see curly brackets and there are just individual kind of scalar elements inside there with no key value set up, then that's a set. So that might be a little bit ambiguous, but just remember, dictionaries, the principal component, the principal characteristic of a dictionary is a key value pair. That always has to be there. So curly brackets with key value pairs, dictionary. Curly brackets, scalar values, just a set. Tuples are the one place where we use parentheses. Again, just to repeat, a tuple is a list that is unchangeable. It is immutable. And so we'll put that data, it looks like a list, but we just put it inside parentheses. And when we do that, we're creating a tuple. One of the things that I'll play with in the end, and when we go over to the command line and play in the interpreter a little bit, Python actually allows those parentheses to be optional. You can create a tuple even without the parentheses. So this is where we merge into this kind of parallel assignment, or this like multiple assignments at one time on one line. It's a really interesting thing that we can do in slightly more advanced kind of Python. But under the hood, just think about it this way, that a tuple is always formed, it's like a list, but it's formed with parentheses instead of square brackets. But in a print, you can actually leave off the parentheses and you get to the same place. Right. Here's a lovely little poem on mutability from 19th century poet Percy Bysshe Shelley. If you want to pause and you want to read through this poem, please do. That's great. Again, mutara, or to mutate, means to change. And so one of the really important concepts that we have to wrap our head around learning Python is we have to understand which data structures can change and which ones cannot. Again, there's no shortcut for this. You have to memorize these things. And so the ways in which we interact with these data structures in our programs is hugely influenced by whether that data structure is mutable or immutable. Again, you gotta memorize these. So we've looked at a list. Is a list mutable? Yes, it is. Because we can add new people with an append, we can get rid of people with a pop, we can sort, we can do all kinds of things with a list. Terrific. Is a dictionary mutable? Yes, it is. We can add new components to a dictionary. We can do all kinds of interesting things with a dictionary. Is a string mutable? No, it is not. And at first, this strikes people as a little bit odd. We cannot change a string. Once we define a string, that's what it is, always and forever. If we want to change a string into something else, like we want to make it a singular thing into a plural thing, we actually have to copy the string and put it into a new bucket. Could we overwrite the bucket it's in? Yeah, we could. But this is one of the things that is maybe not necessarily intuitively obvious about Python, which is that strings cannot be changed. Now, when we get to the slideshow called Objects, I'm going to talk about this a little bit more, and we're going to understand more at that time why Python has made this decision that strings cannot be changed, right? The other one that we've seen that cannot be changed are tuples. A tuple is a list that cannot be changed. So these two kind of have some similarities now. Strings and tuples have this principle of immutability, right? That we can't change those things. Sets, by the way, totally mutable. We can change those as well. So one of the things we do in class at this point, and you can do it at home, is I walk into the room and I say lists, mutable or immutable, and then everybody has to yell out mutable. And then I say strings and everybody yells out immutable. So if you want to play this, with your friends or at parties, you can. It's a great ice-breaking game. So again, just to repeat, strings and tuples cannot be changed. Why is that the case, especially for strings? We will see that in another couple of slideshows. All right, well, let's just drop into the Python interpretive shell here and do a little tinkering around. We'll play with some lists and dictionary. I'll show you some other kind of tricks here. The first thing I really wanted to emphasize is this idea about whether a lowercase e happens to be the same thing as, say, an uppercase e. And according to Python, they are not the same. This is a really pretty crucial idea when we come to do things like text analysis, because if we're counting words in a text, is a lowercase a and the same as an uppercase a and according to Python, no, those are not the same at all. In fact, we can kind of look under the hood to see what that data is. I won't go down this path very much, but this is kind of the numeric data value of a capital letter A. This is under the hood, how Python thinks of a capital letter A. Is the lowercase a the same? You see, nope, they're not, right? They are stored actually as different characters under the hood in Python. So this idea about uppercase and lowercase letters are really, really crucial. As humanists especially, we tend to think that an E is an E no matter what it looks like. But according to Python, if they're lowercase or capitals, those are very different letters. All right. So let's go back to our person. I've just copied and now I have pasted into the terminal window our person, and we've played with this a little before. This is exactly what we were looking at in the slideshow. Is first in person? That is absolutely true. Is William in person? Nope, that's false. And we already know because in and not in with a dictionary look only for keys. So can I ask what the keys are of person? Keys. And the answer is yeah, I can. So here it says dictionary keys, right? First, last, birth, death, citizenship, exactly the way we would expect. Can I ask for the values? Boy, I can't type today. Sorry, guys. Values are Williams, yeah, et cetera, et cetera, et cetera. Just exactly the way we would expect that to be. So again, these are methods. These are things that a dictionary knows how to do. It knows how to give me its keys. It knows how to give me its values. And we're going to experiment with that in more detail when we get to this concept of objects. Namely, that data structures in Python are objects. They know things and they can do things. And so becoming more fluent in Python is really about getting your objects to do things for you, right? Let's review tuples here just really quickly. If I paste the tuple that I was playing with a little bit earlier, these made-up friends of mine, I can ask now what kind of thing that happens to be. And you'll notice that Python does, in fact, tell me that is a tuple. If I try to do things to this tuple that we tried to do earlier, I will get an error message. So if I append someone like Bill Shakespeare to friends, you'll see that Python gives me an error. It's an attribute error, that tuple has no attribute or behavior called append. It doesn't know what that is. It just simply doesn't exist. If I try to pop somebody off the list and get rid of some friends, again, the tuple kind of object doesn't have an attribute or a behavior called pop. And in fact, if I now even try to sort them, the same thing. I can't do that. Don't even try. So again, what this tells us is that a tuple is immutable and that I can't make any of these changes. If I did need to make these changes, I could convert that stuff over to a list, right? So there you go. So this is a type called casting, which is a nice term for it. I'm changing the type of that variable. Casting, I like that term because it reminds me of statues. Like I'm taking a metal statue and I'm melting it down and I'm recasting it in a different form, right? So my friends list, can I append Bill? Again, there he is. All right, one last thing. I'd like to play a little bit with lists and sets. I'm going to barely steal a concept out of text analysis, actually. I'm going to paste something else in my window here. So here's what I've done. I have this string, to be or not to be, that is the question. And what I would like to do is to split that string on the spaces the result is a list, and I'm putting that list into a variable here called tokens. There are my words. We'll see that more of this again when we get to the concept of objects, but this is one of the reasons that Python is brilliant for text analysis. Now, in text analysis, I call these tokens instead of words because sometimes when I split up a text, I'm not necessarily always splitting them into words. Me, for example, I've just done a whole bunch of text analysis stuff where I'm actually, believe it or not, looking at punctuation. So punctuation sometimes is not always a thing that I want to remove out of a text. And so for me, in some of my recent work, punctuation is just as significant, just as important as the words themselves. So in text analysis, we rarely say that we're doing words like this. We often say that these are just tokens. And so here is a list. This is an ordered list. So I can ask it what, tokens 30 is, and it's the word not, which is great. Now, one of the things that we do if we do a word count is that I have to get rid of, I could do this, just by pencil and paper. I write down the word to, and then I put a checkmark 1 by it. And as I go through the rest of Hamlet, every time I see the word to, I put another tick mark by it, and then I count them up. The list of these words without duplicates are called types. And it's easy to make a type list in Python because all I need to do is convert my tokens into a set. So there are the individual unique words that have occurred in my text. So these are terms that come out of text analysis, right? Tokens are all of the individual words and or maybe even punctuation that occur in that text somewhere. And types are the unique words with all of the duplicates removed. Now, one of the things that is interesting to do in text analysis is that we can actually define or calculate the ratio between the number of types that we have and the number of tokens we have. So if I just ask, hey, how many tokens did I have in that particular text? Okay, this isn't all of Hamlet. I have 10 tokens, so the word count there is 10. What's the length of the types that I have? There are 8 of those. And so one of the things we calculate in text analysis is what we call a type-token ratio. And it's actually the length of the types, however many types we have, divided by the length, I can't type again, the length of the tokens. And I get a type-token ratio of 0.8. This is always going to be a number somewhere between 0 and 1. It's actually a kind of an interesting measure of how many words get repeated in an author's text. And in this case, a ratio of 0.8 is actually really high, which tells us that not many words are getting repeated. Some people interpret this as a measure of a writer's vocabulary. The higher the type token ratio, the greater their vocabulary. So we can start to use these kind of measurements between different texts, for example, of one author, or between one author's writings and another author's writings, and we can see kind of who has the biggest vocabulary. Type token ratio is sometimes used as well with children to see how well they're learning a language. If we go out and you do some exploration with type token ratios, there is some debate about whether this is actually a legitimate measurement or not. We won't go down that path yet to find out. If that's something you'd like to explore, go right ahead. But here's the concept, right? If I just go out, I don't know anything about Python, and I'm reading about text analysis, I'm going to see these terms like tokens and types, and I'm going to see something about what is a type token ratio. But now that I know Python, I can take that text analysis knowledge and start to apply that to Python data structures. My tokens are just going to be a list. It's an ordered list. I've still retained the order of those words in the original text. My types are going to be a set, because in Python, by definition, a set removes duplicates. So if I want to find out what the type token ratio is, I create a set, and I take the length of that set, and I divide it by the length of the tokens that I have, and I get my type token ratio. All right. Well, that's it for this slideshow. The next one, I'm going to talk a little bit about two-dimensional data structures, and we're going to play with that. It's just a little bit more complex way that we can join or make a composite kind of structure out of some of the primitive built-in data sets that we've seen already. Thanks.